So what we've seen so far with our domains in a fraction, what can't happen? The denominator cannot be 0. And if you have an even radical, okay, so by that I mean like a square root, a fourth root, sixth root, we can keep going there. What can't happen, or what do we have to have? A positive. So we say the radicand, that's the thing under the radical, has to be greater than or equal to 0. So if it's a fraction, we just say denominator can't be 0. If we have that even radical, the thing underneath, greater than or equal to 0. If we don't have fractions or square roots, what's our domain? Negative infinity, positive infinity. If I'm not breaking either of these rules, then I don't have to worry about it. I can plug in anything. So we were applying that with like adding, subtracting, multiplying, and dividing our functions yesterday. We need to talk about how it carries over into division or composition. And the rules are a little more complicated. We cannot just look at the final answer. Okay, because here's the issue. When you do a composition, we know we're taking x, we do the inside function to it, we get an answer, right? And then I plug that into the next one, and I get my final answer. If I only look at the end, then I might miss something that x cannot equal. So when we're looking at these domains, we have to look at the first thing we do. So I have to look at my inside function and make sure x is part of that domain. And then we are going to look at the final answer. And so we have to check both places, not just the final thing, but also the very first function. Because you took a number, you plugged it into there first, and then you got an answer. We'll talk about why as we go through some of these examples, and I'll kind of illustrate why it's so important. So for the domain of the composition, look at the domain of the inside function and the final answer. Those are the two things we have to combine. Look at one. Okay. On this one, I'm probably not going to do both. It's going to be A. So let's say our functions are f of x equals x squared plus 3x minus 1. And g of x is 2x plus 3. The first thing I'm going to do is find this composition. I'm find f composed with g, and then I'm going to give its domain. So we did the compositions yesterday, but we had numbers. I didn't give you any numbers, so I'm just asking you to compose the actual functions. When you compose them, you start on the inside. So when I say f composed with g, the first thing I'm doing is function g, which is 2x plus 3. Then what do I have to do with that? Okay, I'm going to go to f, and every time I see an x, I am replacing it with the 2x minus 3, because that's what we are evaluating for our function. So both my x's get replaced. Now, should I leave my final answer like that?
No.
No. 2x plus 3 squared. What does that mean? FOIL. We have two of these. By FOIL, we get 4x squared plus 6x and plus 6x would be a positive 12x plus 9. Okay, the next parenthesis, if we distribute the 3, we get 6x plus 9. And then we have our minus 1 on it. Is everybody with me to this point? Combine like terms. So we have a 4x squared. 12x plus 6x is 18x. 9 plus 9 minus 1 is positive 17. So that's my composition. When I want the domain, I told you you have to look two places. The final answer and the first function we plugged in. And we'll see more why in a future example. This one's not very interesting. Because do I have any fractions or square roots? So what's the domain of this one? And what's the domain of this one? Negative infinity, positive infinity. Neither one of them breaks any rules, so when I put that together, my overall domain is just everything. But I had to check both of those places, the final answer and the first function, before I could verify that. Any questions there? So let's do one that's a little more interesting, and not just name infinity. So my functions are f of x equals 1 over x plus 2, and g of x equals 4 over x minus 1. First, let's compose them. So we need f of g of x. And we start on the inside. G is 4 over x minus 1. What do I have to do with that? Plug it into the other one. So I have to go to f, but anywhere we saw an x, we are replacing it with x minus 1. Okay. Is this proper notation? No. We should never leave a fraction in a fraction. There's different ways to get rid of it, but we just go with the shortest, easiest method, okay? So the thing that makes this bad is that I have this extra x minus 1 in the denominator, right? We know it's legal in a fraction if you multiply both the top and the bottom by the same thing. So we multiply top and bottom, that's the same as multiplying by 1. If I take the top times it, 1 1 times x minus 1 is x minus 1. On the bottom, we have to be a little more careful. If I take 4 divided by x minus 1 times x minus 1, what happens? X minus 1 cancels, I get a 4. Plus, then I have to do 2 times my x minus 1. Because I have to take the x minus 1 to every term. You guys okay with me to that point? So top is just x minus 1. Bottom we have 4 plus this would be 2x minus 2. So I get x minus 1 over 2x plus 2. All right, for my domain, if I only look at the final answer, we know that in a fraction, the denominator can't be 0. So that means 2x can't be negative 2, so x cannot be negative 1. Okay, here's why that can't be the only thing I look at. Could I plug 1 into this final answer? Yeah, that's legal. Okay, what if I asked you to do f of g of 1? That says first you have to plug 1 into g. Can you plug 1 into g? No. So if I'm only looking at the final answer, is it going to tell me that? It's not. But if I look back at this original one right here, that's where I see that my x minus 1 can't be 0. So x cannot be 1. This is also not the same as just looking at the 2 original functions. Because what does f say x can't be? Negative 2. But did we get that in our final domain as an issue? No, because if you plug in a negative 2, the first thing you do is put it into g and it turns into another number. Okay, so that's not an issue. So to get your domains, the best option is to actually do the composition, look at the inside function, and your final answer. So we got 2 things that x cannot be. Now, if you're trying to write that as interval notation, it's a little bit cumbersome because it's saying we can't have positive or negative 1. So it means it's everything smaller than negative 1, everything between negative 1 and positive 1, and everything bigger than 1. So it gives me more pieces. My general rule, I want interval notation, but if you have more than one value that x cannot equal, I will allow you to just tell me x cannot be positive or negative 1. So on these, if it's only a single value x can't be, I definitely want the interval. If you get 2 or 3 values that x can't be, go ahead and just say x can't be those things, and I won't make you write the interval for that. Is everybody okay on that one? Let's try another like that. So here are my functions. I'm asking for the domain of f composed with g, so we have to do the composition. Start on the inside. G is 2 over x, and I'm plugging that into x, so that means in function f, every time we saw an x, we are going to replace it with 2 over x. Alright, is this good notation? No. Fraction and fraction is bad. How do we fix it? Okay, so I'm going to take top and bottom times x. On the top, 3 times x is just 3x. On the bottom, 2 divided by x times x. 2 minus 1 times x. Where am I looking for my domain? The original inside and this final answer. So the original inside, fraction, so bottom can't be 0. Final answer, fraction, so inside or denominator can't be 0. So I get that x cannot be 0 or positive 2. Again, if you wanted to give interval, you certainly could. Negative infinity to 0, union 0 to 2, union 2 to infinity. But I will allow it if you just want to go ahead and list it. Questions on that one? Let's try another. I'm going to do one of these and then I'm going to let you guys try one. So we're going to do both f composed with g and g composed with f. If I do f composed with g, so that means f of g of x. Start on the inside. G of x is 3x. If I put that into f, we get that, so that's my composition. Domain. 3x, there is no fraction, there is no radical. What can x be? Anything. All real numbers, A infinity, positive infinity. So you can write that here. If you want to put all real numbers here, I don't care, but remember your final answer, I do want that interval. Right here we have a square root, so what do we know? Radicand greater than or equal to 0. So 3x greater than or equal to 1, so x is greater than or equal to 1/3. Now I have to put them together. This one said it could have been anything, so I don't have to worry about that. So my domain is really just the second one. It has to be greater than or equal to 1/3. I want you guys to do g composed with f and its domain. So the composition, g composed with f, so g of f of x. So f is the square root of x minus 1. Plug that into g, so it's just 3 times the square root of x minus 1. Is that okay? Domains. So we have to look, the original inside. We had a square root, so the radicand greater than or equal to 0, so x is greater than or equal to 1. Final answer, does the 3 on the outside affect anything? No, it's just radical, so thing underneath, greater than or equal to 0. We get the same thing. So overall, my domain is just 1 to infinity. We don't care about anything outside the radical, just the stuff underneath. Do we need more examples like this? So the final thing I want to talk about today is kind of working backwards. If I give you a composition, can you tell me what the original functions might have been? And I'm saying might have been because there are multiple correct answers on these types. You're giving me one possible scenario. Are you sure we don't need more? I've got lots more of these. Find functions f and g such that f composed with g is equal to h if h of x is x squared plus 1 to the 50th. So I am telling you f composed with g is equal to this. That means f of x is x squared plus 1 to the 50th. So f composed with g is equal to this. That means f of x is x squared plus 1 to the 50th. So I am telling you f composed with g is equal to this. That means f composed with g is equal to this. That means f composed with g is equal to this. That means f composed with g is equal to this. That means f composed with g is equal to this. That means f composed with g is equal to this. That means f composed with g is equal to this. That means f composed with g is equal to this. That means f composed with g is equal to this. That means f composed with g is equal to this. That means f composed with g is equal to this. That means f composed with g is equal to this. That means f composed with g is equal to this. That means f composed with g is equal to this. That means f composed with g is equal to this. That means f composed with g is equal to this. That means f composed with g is equal to this. That means f composed with g is equal to this.
softball is dismissed at this time. Girls softball is dismissed at this time.
So this will just be the last little bit on the video if you want to go. Okay. So this is equal to x squared plus 1 to the 50th. So if we work from, look at how this is evaluated. We started on the inside. That's my g of x. What is the inside over here? X squared plus 1. So g of x could be x squared plus 1. Is everyone okay with that? Alright, so think about what happens when you do a composition. When we were working through these, we took something, we plugged it in, and we replaced x. So if we're working backwards, when we take it back out, what's left in its spot? X. So if I am undoing this, I have to think, well, if I took this whole thing out and just left with an x in its spot, that's the outside function. So f of x would just be x to the 50th. Right? That's not the only possible answer. You just have to give me one that would work. What if I had said, if that one makes sense, you can leave it at that, but what if we'd said g of x was x squared? So if you think about undoing it, if you took out that x squared, you would replace it with an x, then f would have been x plus 1 to the 50th. Okay, so there's not only one right answer on these. As long as you have one that works, it's okay. And could you check yourself? Yeah, we want to see. If you do f composed with g, do you get that original problem back? That's all you have to do. Let's try another one. So let's say f composed with g is equal to h, and h is 1 over x plus 1. F composed with g is 1 over x plus 1. If you are trying to undo this, g is the inside. Another way to think about it is that's the first thing you would do. If you are going to plug in a number for x and evaluate this, what's the first thing you would do? What if I said I wanted you to find h of 4? You would put 4 in for x. What's the first calculation you would do? You would add 4 plus 1, right? So my inside is x plus 1. That's the first thing you would do if you were going to evaluate. My outside, f, we have to think about if we undo this, if I take out the x plus 1, what do I replace it with? So just 1 over x. Why don't you guys try one? Find f and g. So we know f of g is equal to 2x plus 3 to the 4th. So g is the inside, so I think pretty much everybody did the same thing here. You said g of x was 2x plus 3. And so f, we're undoing our composition, so we have to think if I took all of that out and replace it with an x, we get x to the 4th. Do we have questions over anything that I covered today? So let's have some time to get our homework.